Set here, and in the new version of Set, I've incorporated Fast Track, which is a tool that I came out with a few years ago that was really popular around automating of penetration testing. I've recoded Fast Track completely from scratch using a lot more better programming tactics. Fast Track was my first Python program, which I don't think I used one comment code in there, and it was just a hodgepodge of code. So since I've actually matured in my age in programming, I've actually commented the code and wrote things that are actually multi-threaded and use the functions and reuse code and stuff like that, which was relatively unique for me. So that's now incorporating a new version of Set. And so we select the social engineering menu, and we're going to go to the website attack vector. We're going to select the Java applet attack method, and for me personally, the Java applet attack vector is by far the #1 most popular attack that I leverage during an attack. Reason being is I no longer really have to attack a browser bug or an Adobe bug or a Flash bug. I mean, when I'm going and exploiting those, you have maybe a small percentage of that actually being successful unless you did a ton of reconnaissance ahead of time. The Java applet attack leverages trust. It's not an exploit. It's not a bug. It's something that leverages trust of how Java is actually designed. And so we're going to go ahead and clone a website, and we're going to do Gmail. And it can be any website you want to. And what Set's going to do is it's going to go pull that website down, rewrite the web page, set up a fake web server, custom compile a bunch of stuff, do a Java applet, and then so on and so forth. And in one of the earlier versions that I released, I think it was 1.7, I incorporated what's now called the Set interactive shell, which is a completely custom interactive shell that's similar to what you would expect from Metasploit or Meterpreter, but specifically customized and designed for Set. And each time a new payload is deployed, it does a randomized cipher key exchange of AES-256. So you have AES-256 communications going back and forth each time. It randomly compiles it and obfuscates each individual time to get around signature-based detection. And it has a bunch of tools built into it. And so we're going to select that. We're going to listen on port 443, and it's going to do everything for us. And so now we have everything listening here. And I just got to grab my IP address. I think it's 129. But yeah, 129. And so I have UAC on here. If you can see, it's set to its default value. This is a relatively recently patched Windows machine. Comes out every 2 days, so we're going to go to 129, and it's going to load the Java website for us. And it looks just like Gmail. And funny enough, and I'll talk about this right now, but if you see here, say someone's like, oh no, I don't want to click on this, and I hit cancel, and they go to type it in. Can't type it in. I hit cancel again. Oh, I accidentally hit run. Okay, so then it actually executes it. It's what we call the Java repeater. So continuously, as soon as you hit cancel, it repops up, cancel, repops up. They can't even type their email. They can't even close the browser unless they kill it through Task Manager, so it's really annoying as hell. And so they're just going to click run regardless because they want to get the thing off of the screen. They have no idea what the hell's going on. And so as soon as they hit run, it redirects the victim back to the legitimate website. So I clone Gmail. As soon as I hit run, it redirects them back to the legitimate site, and everything looks like it's normal. Now,